Hello, everyone. Um, this is my presentation today on scaling your application beyond its limits. Um, quick, quick setting of expectations. If you have any questions or anything as we're going through, drop them in the Q&A that you might see at the bottom of your Zoom window. If I have time, I'll try to answer them, but I have a lot that I want to show you and I'm really excited about it. So I want to try to keep things moving. But if something doesn't seem clear, I want to help you out. So without too much ado, let us get going. Let's see, will it let me? So yes, this is me. I'm Andrew. I'm a senior software engineer at Integral, and I work on a project where we do a lot of streaming events. So, we tend to deal with a lot of volume and a lot of busy services that are trying to do a lot of stuff and need to scale. So this is a compilation of things that I've learned and can share with everybody about things that we recommend to our customers to help their applications scale more effectively when using our services. These are somewhat generic. I've tried to generify them, but if you're interested in looking up and seeing what it was I did exactly, I've provided code samples at the link that you see on the screen there. That's Integral's GitHub repo. And I chose to do this in Java. It is a pretty generic looking language, so I think anyone should be comfortable hopping through there. Don't get buried in the details. But the things that we do here can be done in pretty much any programming language that you might be working in, of course, with variations on implementation in those languages. So, like I said, don't get too worried about the implementation. It's more so to help you out if you're looking for ideas or trying to understand what was going through my head and why did I do those weird things in my code. So here's the agenda for today. We're gonna start with a quick introduction. Where is this going to come into play? Then we're going to move into observability. Then we're going to hit some kind of try to get a better idea of what it means for an application to be blocking and how to avoid it. Then we're going to do some discussion about vertical scaling and how to make your application capable of vertically scaling. And then we're going to get into some horizontal scaling, some of the things in the same category of how do we make it so that our application can vertically scale. And then we'll touch a little bit on architectural patterns that will help our application scale even further. Some of these things are going to be maybe a little glossed over. So if you get a little too lost or something, definitely ask me questions or provide me feedback. And I want to improve this so that if I do this again in the future, it is better for everyone. So starting off with this introduction, some of the stuff I'm doing here is based on some assumptions. I'm assuming that these applications that we're running are containerized or virtualized in some form or fashion. And it's not to say that your application couldn't be just a function as a service sort of thing, or that you couldn't be running on the bare metal. Some of these suggestions are going to be very relevant to those as well, but it became very much easier to show the benefits and consequences of things by going with a containerized application. Additionally, I'm assuming for some of these examples that an average application has roughly 100 milliseconds of I/O, database, whatever, and networking, and maybe 10 milliseconds of actual computation. Those may seem high, those may seem low, depending on what your application is doing. I just chose to go with something kind of generic. So anyhow, assume that you have some application, maybe, you know, a popular word guessing game, or at least it wasn't popular when you started, but suddenly it became popular. I'm sure none of us can think of anything like that, though. Like, who'd do that? But you know, you created this app and it became popular. Boom, and then traffic happened. And I kind of was like, uh-oh, I don't know if we can keep up anymore. But the real question is, how'd you know? Oops, there we go. Sorry, wrong way. How did you know? Oops, looks like I'm having some technical difficulties here. Oh no, I think my application is maybe failing to scale. Oops. Oh, there we go. How did you know? Well, it might have been something like that. You know, you started getting some errors from your server saying, I just couldn't keep up. I couldn't respond. Well, that's not the place that you want to be when you find out. You're going to want to be a little bit more aware before it happens. And that's what we're going to try to get into. Everything is like, was it for you? Was it sudden? Did this happen like overnight, or was it like a gradual buildup? And then how did you recover from it? Like, did your application, you know, manage to come back on its own when the load dropped? Or, you know, were there things that you were actually able to do? What we're going to get to today is making it so that you can hopefully have some control yourself over bringing your application back, rather than waiting for the consequences to subside. So say this, there's no silver bullets on anything today. I'm definitely going to be saying that you'll need some code changes to make sure that your application can go beyond its current limits. We won't get into the code. I have too much content, unfortunately, but that's why I encourage you to check that GitHub out. And keep in mind, your mileage may vary depending on what your application is doing. So first up, I want to discuss observability. To me, this is so important. Observability on its own needs its own presentation, but for the purposes of this today, I couldn't really show what is going on in your application if it wasn't for tools that help me see what's happening. So when you are trying to determine what's going on with your application, depending on just something like logs or checking endpoints is not the place that you want to be. You want to have something that can proactively let you see that something's happening in your application. So I encourage you to, if you can, always make the forward investments in observability. Some might say you ain't gonna need it. I'm gonna say you're gonna need it at some point. Additionally, observability eases your understanding. You know, this graph here tells me so much more than just a snapshot at any given point in time that I might get from a single log. I know how it's performing in this case over the course of you know, 30 minutes, and I can see that something started high and it got low, or at least went down a little bit. Also, they look really cool. I actually specifically picked this one out just because it had lots of lines and colors on it. And the more important part is that it's critical in decision making. This probably should have come a little higher, but I thought it was better to come back to the important bits. For me, based on this graph, I know that maybe I made a decision right around that 155 mark that you see right here. You know, that could have been because of a decision that was made. So that's what this is to me. So now let's get into what we're really interested in, doing something about it. So first up, let's talk about blocking. Now, this is something that's going to happen in every application to some degree. You're not going to be able to avoid all blocking whatsoever. But what I do want to say is that there's a couple of types of blocking. There's I/O blocking. And I/O blocking in my examples, if you're looking at any of the code samples or as you're watching the recorded demonstrations that I do, they're simulated with a thread sleep. And since I'm doing Java, thread sleep just basically means that the thread just stops processing, it's been set aside, and it's going to come back to it when that time is up. Consequences of typical applications when they're like, okay, well, I'm going to come back to this later, or maybe certain components of things that you utilize in your application might be doing the same sort of thing. And then the other type is CPU blocking, which is the actual processing your application's doing. So, for me, I simulated that today in my examples with a while loop with a timed breakout condition. This is a really bad idea in your own application because it's going to keep your app really busy. It's going to be looping as quick as it can. And that's what I did here today to simulate an application that's just chugging, trying to do as much as it can. So for these first demos that I'm going to show, there we go. I wanted to preface that I'm going to be running 2 applications here concurrently that we're going to see in some graphs. The first one is going to be doing some I/O blocking, and the second one's going to be doing some CPU blocking. And I've designed both of them to just randomly choose to block for anywhere between 10 milliseconds to 100 milliseconds, which means that it should average out to about 50 milliseconds. So let's get to it. So here we are. I'm going to start the video. These were pre-recorded. This one here, we're seeing the application is starting to run here. We got some pointers that'll come up here and give us some info. So here we have our I/O. It's running at about 18.2 operations per second, or 18.2 tasks. And here's our CPU. It's doing about the same. And our processing time for both of these is pretty consistent at about 55 milliseconds. So right in the range of my preface that I gave you. But if you look down here over at the CPU for both of these, our I/O is running at about 4% or less, 2% there. And our CPU is pretty much maxed out at 100%. And that's because I'm just purely pumping as many jobs through this little sample app as I can, as fast as I can. And that's the gist of it. Like, this is the difference between these 2 types of blocking in your application. And that's a basis of what it's going to look like when you're trying to make decisions and figure out what your application needs to do. So let's come back over here and talk about some little things. Right here. Okay. So in a more realistic world application, you're not going to be doing all I/O or all computation. You're probably going to have some mixture of these things. And it's going to look something more like this in a typical application. And I've kind of highlighted this without any of our optimization opportunities in place. So you might have a controller with some domain logic. And typically those things are pretty skinny. They don't have a lot going on. You might have some sleeps in there, or some of the things that some of the libraries you're using might have some sleeps occurring in them. And then you're going to have your I/O activity, your database calls, your network calls, your file system stuff. And that's the stuff that, by and large, is going to take up a lot of your time in a lot of applications. Oops, get this one off. So one of the first things that you're going to be able to do is just introduce some basic caching and, just trying to do a few of the IO blocking things parallel. Your application is just waiting anyway. So, get the benefit of just kind of, doing them side by side. Don't stack them if you can. Try to parallelize those things. My examples don't really get too deep into the actual how to do this. I'm going to leave that as an exercise for you so that we can get into the nitty gritty stuff. And same with caching. But caching is one of those things that, if you can just save the time of not needing to do stuff, do it. And then that brings us to concept of a kind of optimized real world situation where not only do you have caching, maybe you're doing some memwising, or maybe some additional in-memory caching, something that is right on the same metal as the application that you're running. And then, hopefully you're also maybe able to optimize your database operations with some batching. Try to, group database operations together. Some applications, some frameworks give you tools and to make an application easy to stand up real fast. But sometimes they're kind of chatty and they do a lot of back and forth. And by simplifying your application, having very specific use cases, batching operations, especially like operations together for different requests even, can really help to speed things along for your application. And then I left the service calls here still kind of as a big red block because this is something that's kind of not in your control totally. Your service calls might still take time. Ultimately, if you need to wait, you're going to be waiting on your service calls, and you're dependent on other services most likely for those. So I'm going to hop over to a demo, and this demo is going to be trying to show you this last one here, which I'm going to call a realistic looking application. This is our realistic real world best case. So switch over to this video and get it going here. So this one's going to fast forward here in a moment after some initial startup, maybe. Looks like it cut out for me here. Let me try this again. Here we go. This looks better. So here we are. We're just kind of running along here with an application that is on, running on a single thread, just processing, doing its thing, combination of I/O and CPU. In this case, I/O is doing 100 milliseconds, CPU is doing 10 milliseconds. We're doing about 16 operations per second on a single thread, and our average response time is around 60 milliseconds, and our around 55 milliseconds. And our effective response time here is at 6 milliseconds. And what I mean by effective response time is that this is how frequently we're actually able to bring in a new operation to be processed. So when can we start processing more data? We're able to do that every 6 milliseconds here with this current model that we're using, which I'll get into a little bit more in a second here as to what this model looks like. But we're going to hop along here, take a quick break. I had to do a few test trials here, and then here we are, we're recording again. This time, cranking the speed up. We just scaled up to 2 threads now. I popped a second thread of doing the exact same thing onto my app. And looks like we're doing about twice as many events. We're still responding in the same amount of time. You can see here, we got more actual running threads, and the CPU went from 10% to 20%. So definitely showing that by adding additional threads, we're getting more out of the CPU. We're not wasting that effort. So here we go. We're going to fast forward again here. We're going to scale up and scale up. So we doubled again and we doubled, and we're adding like 10 more threads till when we get here towards the end of the fast forward. And here we go. So at this point, I decided to pause because we've kind of gotten to the point where we're maxing out the CPU. We got there a little while ago, but we've maxed out the CPU. We're processing about 280 operations per second. And our response time is starting to edge up, but we had been increasing our operations per second. But now this is the first time that it decreased. Let me go back and just allow that to be a little bit more clear. We went down from 280 to 270. So this to me is the critical thing when we're looking at like what's going on with scaling here. Like this is the point where as we were adding more threads and trying to force our application to process more data in this case, that we crossed a threshold where our application started to lose performance. So we were no longer getting more out of throwing more at it. As we were watching this video, you can see back here when it was really going, it was getting that higher CPU kind of early on, but we kept scaling, like we kept getting more processing out of it, but that CPU stayed at about 100%. And the way it did that was by keeping these processing times up here by just getting longer. Like ultimately time is king. So when your CPU can't process enough, it just, makes your operations wait longer before they can finish competing. And I want you to keep that in mind as we continue to talk about like service call response times and services that you depend on, because that's where this comes into play. So let me hop back to my slides. Always going the wrong way every time I do this. Okay, so here's how I basically did that in that demo. I had a producer loop, which is for me effectively the front door of my application. So say like my controller, and it might be jammed up there with my HTTP server. So assume that if this is a Java app, maybe I'm using Tomcat or something like that. And or maybe if I'm in PHP, Apache, or something along those lines that is just constantly receiving these events. And so that concept that you saw of me, scaling up and adding threads is sort of the same thing that your HTTP server is handling for you. It's forwarding things along to your application and spinning up threads or processes as necessary to handle things concurrently. So for all intents and purposes, that's not going to be a big deal for you. But we'll talk a little bit more about that later. But that brings me to the next point is that I implemented this with this kind of blocking queue. And I did this to provide back pressure, specifically so that my application could actually say, hey, I can't take anything more. And that's how I kept my CPU from just completely crashing my application here. This is the same sort of concept as to how the underlying services are probably doing it for your app too. And then lastly, I have my control loop, which is basically just a consumer that's continually taking the things coming off of that queue and letting the producer loop know, hey, I can take more stuff now as it finishes. And this is kind of basically a simple event loop that most applications are going to run in as they're doing their thing. They happen at different scales and different places of different applications. But that's what we're doing. So this is the model that I continue to use throughout these examples. And again, you can go and look at that code repo that I linked to earlier in the slides to see how I achieve this. But next up, I want to get into kind of like an ideal world where we can, get rid of all those sleeps. So I also created an idealistic application. And the way that I started to get rid of these sleeps is that I said, hey, let us just stop doing the sleeping, and let's do something more like a promise or a future, as you might be aware of in different programming paradigms. And you're going to see that kind of be really useful in being able to handle more load here. And I have a demo to show that. Woohoo! More demos. So let me cue that up here. Let's get this back to the beginning. Okay, so this one here is the same I/O demonstration that I showed you earlier, except this time it's doing the promise pattern. And we're hitting like 57,000 operations per second on a single thread. That's pretty crazy when you think about it. Like we're still responding, you know, here in an average of 31 milliseconds to these responses, but it's the same thing. Like just let that sink in almost. Like this was still amazing to me. I didn't expect it to be so high when I was running these demos or putting them together, but like just because your application is doing some sort of I/O doesn't mean that it can't do something else. And that's the cool thing about like those reactive patterns. And these reactive patterns are useful in a lot of different languages. There's a lot of libraries out there that can help you put them together and make it work and squeeze more out of your app. And look at that, just sitting there, chugging along, 60,000 operations at 100% CPU. Like that is like night and day different from the previous I/O example I showed you a moment ago. So with that, let's show you what that looks like in the same like concept of that realistic application where we have I/O and CPU blocking at the same time. Excuse me. So this is the same thing, 100 milliseconds wait time for I/O and 10 milliseconds of CPU processing time. And we get this thing running here, and we're already kind of like doing a lot better. Our operations per second are already at like 180. Mind you, with our threading example, our other threading example, we are higher with more threads, but already with one at 180. And our CPU usage is already pegged, which means that we are as efficient as we can be. Our max response time is kind of high, but you know, our average response times, I think we're going to see are a bit better here. And this was running up against the previous example that had more threads running. But you can see down there on the lower right that they were lower. And yeah, look at this. Our effective response time is up around 80 milliseconds, and our actual response time is around 80 milliseconds. Our effective response time is down around 15. And here we go, fast forwarding like we did before. We're doing the same thing. We're just adding threads in the same way that we did with our realistic example before that wasn't using promises, and just keep adding additional processing threads on here. And so here you go. You can see we got quite a number of running threads. Our CPU is still maxed, and here we're up to processing 300 events per second. This is stopped here because this was this was the first point where we peaked above the threading example. And our effective processing time compared to the other one, though, is much higher. We're taking almost 600 milliseconds to respond sometimes, but you know, our effective processing time is still low. It was down around like 3 milliseconds, I think. I missed it. Let's speed up again. Keep the speed going. So here we added some more threads again, and we're still getting higher. That's the thing. We haven't maxed out yet. We're still getting better. And here we are. We're up around 320 operations per second just by adding more threads to that idealistic application, you know, squeezing as much as we can out of our CPU. And so, yeah, my recordings. I irritate myself sometimes with how I do things. Get this going, cruise it along here. Let's fast forward. So we keep this thing moving, and then here we go. I think this is the first time where we see the actual operations per second drop again. So again, this is where, just adding more threads or things to try to help your application stops working. Like you've hit your limit. So, with this sort of experimentation here, I've shown like there's going to come a point based on whatever your application's doing. We're just trying to give it more is not going to get you any further. You're going to hit a wall, just purely based on that. And so, yeah, we max out here around 800 milliseconds of like actual response time, even though our effective response time is down around 3 milliseconds. So still, that's pretty impressive stuff for an application that's doing 10 milliseconds of processing, CPU processing, and 100 milliseconds of I/O. So let's see if I can go back. Cool, I went back to the right screen this time. So that's going to bring us to vertical scaling. So now that we've gotten to the point where our application was like really like performing and doing its thing, just with the basic resources we had. If you hit a situation where you're like, you're not ready for horizontal scaling and your application needs to scale, like the first thing a lot of people are going to think is like, wow, I need to do some vertical scaling. So that's the first way to just squeeze more performance out of your application. So what does that mean though? It means that your application must be able to utilize all of its system resources as you scale it. So that basically means that if you're not doing any threading, then you're not doing any scaling as you potentially add more CPU and memory to your application. Now, I don't want to confuse anyone here because remember I mentioned before that if you're using something like Nginx or Apache or Tomcat for your application, it's kind of covering a lot of this for you. But the problem is when you're using something like a single threaded reactive loop. Those, if they're not programmed to scale and add threads for your application, this is where you're going to start hitting your bottlenecks. Your application actually won't be able to utilize what you're giving it. And that's really what I want to drive home here. And I'm going to try to show that to you now. So let me see if I can get this video to load. Go. So already fast forwarding, and what you'll see here is that, and I just paused it, and it's going again. The first half here, we were running with one CPU, and then we added a second CPU. But the operations per second up here in the that you see are basically the same. It went from 180 to 180, but our CPU was cut in half. So the only thing we did by adding an additional CPU here is drop the load on our system, or at least one of the CPUs. The other one's probably still up there. And so here we go. Now what I did is I added that second thread for the single threaded reactive loop process. And here we go. We're back up to 100%, and we've doubled the amount of things that we're processing, which is essentially the point that you'd want if you're trying to scale your application vertically. But to drive the point home, I added a third CPU here to my Docker container. And you'll notice that, again, our operations didn't increase, but our CPU dropped. We're just not pulling anything. So, one more time here, I'll show you that by adding another thread to the mix, that it helps bring our CPU usage or utilization back up to 100%. And boom, there we go. You'll see that, again, we increase our operations per second that we can handle just by vertically scaling our application. And it also helps bring down our overall response times and our effective response times. And in the bottom right corner, you can see that the threads per instance are also happier. And so let's see, what are we doing here? Yes. So here I decided to cut us back down to 2 CPUs, but this time I just added more threads. So this is kind of a little bit of a comparison of where we were before. And now the cool thing is we're almost operating with 2 CPUs there, and the sort of optimized number of threads that we found from the previous example at almost the same level as 3 CPUs with just 3 threads. So that's showing how important it is to squeeze what you can out of your app before you start implementing the scaling. And so here, again, I added a 3rd CPU with an additional scale factor to the number of threads. And here we go, squeezing out of a single instance of our application, 700 operations per second. So yeah, this is the point that I want to drive home, is just how important optimizing your app is before you start to try to introduce the vertical scaling to the mix. And here's just a look at the whole graph over that whole period of time. Like we started down here with 1 thread, 1 CPU, and boom, all the way up there. So yeah, I see a question in the Q&A section here. Yes, Richard. I believe that the code sample is available on Integral.io's website. You should be able to check that out on our GitHub. It's called scaling or webinar scaling. Anyone else that missed that earlier on in the presentation, you can check that out too. Okay, so here we are. We've managed to vertically scale our application. Now let's see what it's going to take to horizontally scale it, and maybe even what does that mean? Horizontally scale it and see maybe what that means. So I start off here with a drawing, but I'm going to add some text. So the most important thing for a horizontal scaling application is that your application has to be able to share information between instances. So that means like you're running more than one container or application or version of your application concurrently at the same time on another computer maybe. So you know your applications have to be able to share information. That's the minimal quality that your application requires to scale horizontally. And so I took our earlier drawing and I modified it slightly, and I drew the caching layer to kind of underscore that it's shared between all of the instances of our controller and domain logic. But try to kind of give the same essence that like you're still doing your batching and database stuff, maybe on a per instance basis. But because of the caching, you're going to be able to utilize it from all of your other instances. Service calls are still kind of the lingering item here. They're still shared between all the instances, so you're still going to get the benefit, but you are going to still struggle because those could still be the big issue, your bottleneck of things that are outside of your control. And then lastly, the big change to this is the load balancer. Again, if you're in a managed infrastructure, it's relatively easy to get a load balancer stood up in front of your application. This isn't so easy if you're trying to do this on like your home network. It's not impossible if you're doing some cool stuff with like Kubernetes or something, but it's a little bit more challenging if you're trying to set this up on your 10-year-old laptop that you don't use anymore. Oops, a little too fast there. Yes, and I managed to completely talk past my second point to the slide, which is each instance must be equally likely to receive a request. So you don't want to have one instance receiving all the load. That's going to be bad. And so now I'm going to hop into another demo where we actually show what horizontal scaling looks like and how it's different from our vertical scaling. Pull that one up here. Okay, so here we are, similar view. We're coming back down to an application that is running with, I think this is the 3-threaded 3 CPU example here that we're running from before. Oh, hang on, my brain. So yeah, this is already showing you the 3 applications running concurrently. This is what I did here. The one on the left that it's currently selecting is the one application with 3 CPUs, everything. And then here we are over here. This is the multiple horizontal instances. So we're letting each one of these things take as many requests as they possibly can. And each one is doing its own work. That's what the bottom line there is showing, is the processing power of each individual instance. And the upper line is the processing power of all 3 of them working together. Many hands makes light work, so they say. And you'll notice like 3 horizontal instances is performing with 1 CPU each, is performing better than the single application with 3 CPUs. And I think it's 75 threads or whatever, my scaling factor. So like, there you go. Like there you have it. Taking multiple applications and scaling horizontally can immediately, depending on your use case, potentially have a benefit, giving your application power. But let's continue to drive the point home, because if something's worth doing, it's worth overdoing. And let's do some fast forwarding. Here we go. So here I did the same thing where we added the 3 CPUs and the additional threads like we had before, and just combining our factors here so you can see what happens when you are both vertically scaling and horizontally scaling. And on just 3 applications, we're already handling 2.2 thousand operations per second effectively, and getting essentially the same performance as a single application running. So about a 600 millisecond response time and an effective processing time of around 1 millisecond. Just insane. Awesome. Like, our application's scaling. Yay, we did it. Whew. But we're not done. If I can go to the next slide. Yes. So real quick, I want to touch on my last point, which is, horizontal scaling architecture. And this is something you'll have to investigate for yourself. This isn't going to work for every use case or situation, but these are some pretty common patterns that we can really utilize. The first one here is this producer-consumer flow, which is pretty similar to the one that I showed you earlier in my presentation, except instead of the inner app flow that I was showing you before of like the code of a producer and a consumer, now, this one's trying to show you where like you actually have 3 separate services: a producer application, a consumer application, and some sort of application that's helping to shuttle the information between your applications. And this is like the foundation of getting into event-driven systems. Like when you can start looking at systems that are simply handling events and doing them as asynchronously as possible, like you are maximizing the scalability of all the pieces. You can scale individually your producer, your consumer, and your queues as necessary to handle what you need to process. And that brings me over to this sort of wagon wheel or hub type look. These have a few different names. Some might consider it sort of like an event cloud. And these are some of the things that you really see in like super high scaling applications that are trying to say, hey, we have all these different queues. We have different things that are producing messages, and we also have a bunch of different things, different applications that maybe we want our consumers to use that are processing some of these messages. Each application might not be interested in each one of these things, but different applications might be interested in different sets of these. And so that's why I kind of have these arrows here of saying, hey, you know, this app down here has an interest in the same things as up here. And so does this one. It's interested in this and this. So it allows these applications to kind of mesh these activities of your business together to get at and drive home these powerful things to make your application scale, both for the immediate need, the future need, and hopefully maybe even your business, if that's the use case of how do you add more applications, add more functionality safely. How do you actually do microservices in a way that doesn't just create a cascade of applications interacting with each other. That's what these kind of hub wagon wheel models start to give you, is the ability of applications not depending so much on individual services, so much as collections of data or information or messages. You know what? I was working on this presentation right down to the last second, my anonymous attendee, but it is there are actually a lot of resources. These models are pretty. Let me get back to you, because that is actually a great question, and I wish I had more time to compile a list for you. So that's a great question, and I'll make sure to improve my presentation in the future to answer that. So lastly, I have a recap here, and that is, number one, start by understanding what your app looks like while it's running, observability. Know what it looks like when you have high CPU, low CPU, high messages, low messages, and go from there. Next up is, minimize the time that your app spends waiting. Figure out how to make it wait efficiently. If it has to wait, have it do something else. Introduce caching layers, minimize database queries, try to batch your network operations when possible and database queries. It's these types of things are going to help you squeeze every last little inch out of it. And then, utilize some of these scalable patterns like we were showing, which I'm going to try to produce some resources for. And then you can get into the concept of scaling. Based on the information we collected, determine how your app scales best, either vertically or horizontally. But remember that vertical scaling is ultimately going to max out. You're not going to be able to just scale vertically indefinitely. At some point, you're going to have to choose to scale horizontally. And again, utilize scalable patterns as you build more systems and more interactions. And that's it. So I'll leave you with some parting words and a little bit of a script. If you're interested in a more depth discussion of this subject or anything else software or team related, I welcome you to take advantage of our pro bono office hours. It's a 60-minute session where we do a deep dive into a problem you're looking to solve and help frame up some solutions together. Let's nerd out. Shoot an email to hello@integral to set it up. And with that, I'm gonna, open it up. Let's get some questions in here if you have any. I see one from Alonzo. Out of curiosity, were you playing Wordle before it was popular? No, I definitely waited to help them scale their application when the masses got into it. So I am not trendy. we have any other questions? I got a few minutes, so I'll just sit here if you want. I'm cool. You're also, I think, hopefully able to unmute yourself. I don't know if we've allowed that yet. Peter has his hand raised. Let's see if I can allow him to ask. I don't know, Lindsay, if you're able to help me. Is Peter still wanting to talk? Or maybe he can post his message to Q&A.
I've checked the ask to unmute, but it's not actually unmuting him. So yeah, maybe if you do have questions, if you could put them in the Q&A, that would be great.
For anyone who was here earlier, I'll go back and show the slide where I show you how to get to the GitHub repo, in case you want to go check that out. Kelly has a question. He says, what is the funnest piece to implement? Observability, optimization, vertical scaling, or horizontal? Those are really good questions. I would honestly say I think my favorite part was actually when I started deep diving into the reactive promise pattern and seeing that like 60,000 operation per second response. Like I wasn't expecting it to be that high, and just pairing it with the model with the producer consumer was just super cool to me. That was sort of a late development that I added to the presentation, and it just blew my mind just how much better it was. Cool. Well, I'm going to guess that maybe there aren't too many more questions, so I hope everybody really enjoyed this presentation. Well, we got one. Yeah, so reactive programming principles is one from Peter here. Basically the concept to the reactive programming is that you think of everything that your application is doing as like a task, and you are just stacking the tasks up and running through them in a loop. That's the main outer model of this reactive programming concept. But then when you need something like like if you're doing network calls or database operations, you need to have some sort of callback. And so if you go and check out the GitHub repo that I have here, the way that I deal with this is I added some callbacks to my code that essentially threw another scheduled task onto the same running thread that everything else was happening on. And so everything just had to continually share their processing time when you're running on a single thread. But it threw these tasks onto that queue that everything was running on. And when its time came, it said, hey, I already have this answer here. Would you like to do something with it? And I said, yes, I would. But I also left an opportunity for something to go wrong and say, hey, if it doesn't come back, then do this instead. And I, sort of intentionally made sure that happened. I see a question from Kelly. Did you use Docker to deploy multiple instances of your app? Yes and no. I did use Docker. I used Docker Compose for these demos. I didn't deploy the app. This was all just running on my desktop here so that I could easily record the screen. But yes, and the observability bits that I utilized and did, as well as the Grafana graphs, as well as the way I implemented observability in my app are in that code repo, so you can see how to do it. I'm sorry, I don't know how to pronounce your name, but I see a question in the chat. Adrian Wilson, is there one piece of information that a newbie should take from the presentation? Yes, observability. At the very least, start off with observability. Know what your app is doing. You know, start knowing and being able to react to your application from day one based on actual data as opposed to intuition. It'll just help you out so much. Everything else, you have, you know, the time to get there. Okay, I'll go back to, oh yeah, I got more questions. You guys are making me so happy. I love getting questions. Would you speak a bit more how to get to the level where you trust the observability? Can it be set up wrong to draw wrong conclusions? Yes, absolutely. That's a really good point. You know, you definitely have to, you know, have a concept of like what it is you're trying to observe in the first place. I definitely had a concept in these examples that I set up where I said, hey, I want to show how my application is performing. And so I targeted my data at that. And like I said, this could be its own presentation in and of itself. But like, and you know, maybe that's something that I should do here. But at the very least, you know, focus on like knowing what it is that you want to observe. And that's going to go a long way towards getting it set up correctly. Because you might get it wrong initially, but you can evolve it just like any code. All those formulas and those graphs and everything, they're just code. So you can evolve it and get it better over time. You know, it's an experiment. You know, take a scientific mindset, and if it doesn't work, you know, try again. You know, it also plays into, you know, TDD. Yeah, these formulas, you can't exactly test drive them, but if you go in with a hypothesis of what you expect to see, you can at least compare your expectations to reality. I have another anonymous. Can I start with multiple apps, i.e. horizontal scaling? Sure, actually you can if you think that you need to. That's definitely why I encourage the concept of you know, observability so that you know if it's even necessary. And you can also, that's also why it's important to have like a database layer so that you can communicate between those apps. However, these things just add that complexity. You know, your application is going to be more complex from the get-go. So if you're trying to definitely, you know, focus on being a lean, agile process of, you know, only building what you need, you know, maybe not the best idea, but if you know that the application that you have to build has to scale on day one, maybe some other app depends on it, you know, horizontal scaling on day one, yeah, it might be the right thing to do. And then I have a great question from Ashok. Did you intentionally plan on wearing the same shirt as your photo? Actually, I thought the same thing. And my wife thought the same thing when she picked it out for me this morning in the dark as we were getting up. And turns out this is not the same shirt. This one's actually gray. But I think my camera makes it look more like the same. So yeah, I've gotten that question multiple times today from people that I pre-ran this with. So yes, thank you. Very important. And I really appreciate that question. Cool. Thanks, Ashok. Okay. Thank you, everybody. I appreciate everyone. It's 1 o'clock. Everyone have a great day, and feel free to reach out to us and learn more about all of this.